Hey group, so this lesson is all about our eyes and kind of really answering the question, how do we see? So something that we do constantly that we probably don't even really think about when every time we look at an object or whatever, seeing things, the actual act of like turning those light rays into an object is pretty complicated. It involves a handful of parts. So that's the main mission of this lesson, is so you walk out of here knowing, how do I actually see the things that I'm seeing, okay? So the first thing to take a look at is like, how do we see things in general? So this is kind of physicsy, but what's really important to know is that it all stems from light rays. So whether things emit their own light, like flashlight or the sun or whatever it is, but most things like chair, table, notebook, really is reflecting light of some sort. And you know that because if you turn off all the lights, well then you can't see the notebook anymore. So either way, we're talking about light rays coming to our eyes, okay? So it's coming from an object or from a light source, okay? So anytime we see something, light rays come to our eyes. And then when it gets to our eyes, what happens is we take that image or we take that light and we basically focus it into an image. So we're gonna really take a close look at like all the things that come together to make that process happen in the eyeball. So there's lots of parts to the eye, lots and lots of parts. We're gonna focus on these 6 parts that I've circled for you in yellow. All right, so let's start off with the cornea, so from the outside in. So cornea, C-O, I always remember, covers the eye. So this is your outer covering of the eye. Like if you were to actually touch your eyeball right now, please don't do that, but if you did, you'd be touching the cornea. Sometimes you can scratch your cornea. So this is the outer layer of the eye, and what's so important about it is that this is the outer layer that does most of the focusing of the light. So when those light rays come, hit our eye, they start to focus it in, which is gonna be really important so we can see that image. So the outermost layer that focuses the eye is that cornea. And then we have what's called the pupil. The pupil is so cool for a couple reasons. One, because it's not even really a thing. So what I mean by that is you see people's pupils and they're black, and it's almost like you think that there's something to it, but really it's just a hole. So the pupil is really a hole inside of your eyeball. And it's where the light enters. It's the entrance point of the light. And it's not even a thing, it's just a big empty black hole. And it's black because there's no light really in the back of our eyeball, so it looks like, it's black. So it's really like a black hole inside of our eyeball. So this is where light comes in. So the cornea takes it, focuses it, goes through the pupil. And so you've noticed that your pupil can change in size, and that's really important because ultimately if it needs more light to come into your eyeballs, in a really dark room or something, your pupil opens up and lets a lot of light, so lots of light into your eye. Or if it's crazy bright outside, like you walk outside or you look at the lights, it's too much light, so your eye will constrict the pupil to be much smaller. So your eye does a phenomenal job of deciding how much light it even wants to let into your eyeball in order to see things, okay? So the way it does this though, is that there's this muscle around it. There's a muscle around our eyeball, around our pupil, which opens and closes it. And that's our next part that we're gonna talk about, which is the iris. So the iris is probably what you think of when you say someone has like really nice eyes or something. It's the colored part of your eye. Okay, it could be blue or brown or green or hazel or whatever. This is the colored part, but really it's a muscle that opens and closes, like I said in that picture before, and lets light in. So that's what your iris really does. It's the colored part of your eyeball that decides how much light gets into your eye by opening and closing that pupil. Okay, so this is this iris here, opening, closing. Again, it's the colored part. All right, and then what happens is, so we have our cornea, we have this opening, this hole is a pupil, and then we have here the iris, okay? And then as soon as light hits it, there's another lens. Kind of like, again, like when I say lens, picture like if you're someone who wears glasses, like a lens, like literally, like almost like a little kind of bulby thing in your eyeball that is gonna help focus light again. And this is kind of more of a fine-tuning knob. So what I mean by that is, this is what lets us see things that are near and far, and kind of does that little adjustment to make sure that we can see things nice and clear. So even though light has already come in, the cornea did most of the focusing, the lens is that like fine-tuning. So here's what I mean. So what I want you to do right now is like hold your thumb up, all right? And you can look at me, the teacher, you can look at really anything across the room, but if you look at that, let's just say teacher or book across the room and you hold your thumb up, if I'm looking across the room, your thumb's a little blurry, okay? Because your lens has just basically adjusted. Your lens literally squishes and spreads out a little bit to do that fine-tuned adjustment. So right now it's making sure that thing across the room is clear, but when it does that, the things close are fuzzy because it can't make both of them clear at the same time. Where on the flip side, if you now like are looking at the same exact thing, only you focus on your thumb, now the things behind it in the back of the room are fuzzy. because again, this is what your lens does. Your lens decides, you decide basically what's far and close, and your lens will do that fine tuning to make sure it's nice and clear and you can see it, okay? So that's what your lens does. All right, so like I said, objects come in, the cornea takes it and starts to bend the light, the lens does the fine tuning, and then ultimately so it can hit the back of the eyeball. It's actually upside down, which is a whole different ball game. Your brain kind of flips it, but we're not gonna worry so much about that. All right, now the retina. This looks kind of confusing, but retina is like the receiving spot. So you're gonna see this is the spot, the purple, that's all in the back of your eyeball. So after the light has come in and you decide the pupil lets how much light in and it bends and all that stuff, ultimately it slams into the back of your eye. And this retina, this is what receives the light and ultimately turns it into some sort of image. We have these things called rods and cones that determine color and so on and so forth. But what we're going to talk about right now is basically it takes those light waves, those invisible light waves, and it changes them into what are called electrical signals, which is really how our brain and our nervous system works. It's a whole bunch of electrical signals. So it's like a conversion factory that turns light into electrical signals. So it looks as when the light hits it, it basically says, oh, that textbook is green, and it sends a signal to tell your brain, hey, the textbook is green. Or that's really, really bright, and it sends text, it translates the signal. So again, it takes those light rays and it translates them into something your brain can understand. This is definitely the tricky part. I always think of retina, RE, like the receiving end of the light journey, I guess, okay? So after it does this, and it translates it and turns the signal into electrical signals, then what it does is it has to send it to the brain on this huge highway. So this highway here, it's a real eyeball here, okay? It travels on this optic nerve, a really tough bundle of nerves, again, like the nerve highway. So after it takes it all, it sends it to the brain, and then again, the brain does its thing and ultimately interprets the image. So your main function of the optic nerve is it translates electrical signals that the retina just created from the retina to the brain. Again, it's that major highway. So that is your optic nerve, okay? All right, so this is kind of like the summary. What I want to make sure that you can do is ultimately summarize, well, how do you see an object? So light comes from an object in some capacity, okay? Your cornea focuses most of it. Then your iris is in charge of opening and closing that pupil, decide, okay, how much of that light comes in. And then after it comes in, the lens will fine tune it, depending how far or close it is. And then your retina will ultimately get it, turn it into electrical signals, send it through the optic nerve to your brain. All right, so this is what I want to make sure you can do as opposed to just simply memorizing parts. Can you do this and understand how, when you look at something so simple as a pencil, all this happens to make sure that you can see it? All right? The next part of our PowerPoint is a couple of things I just want to get into about some difficulties. And there's lots of them. There's lots of different diseases and so on and so forth. I'm just really going to focus on kind of the most common idea of like nearsightedness and farsightedness and kind of that kind of thing, and a blind spot. So I'm going to just do a little bit here, and there's so much more. So the first thing to remember is that this is what normal vision looks like. If your eye works perfectly, light comes in and it sharpens right at the retina. Okay, and so I always think of it like a pencil point. Okay, like you want your pencil point to be really sharp, so your image that you're looking at could be really sharp and not fuzzy. But the thing is, that doesn't always happen. Sometimes something like this happens, where the light will come in and the sharpness where it meets to be as really sharp is actually before it even hits the retina. So then it keeps on going and ultimately ends up spreading out. So when it hits the retina, it's like fuzzy. Okay, so again, like it's the light is converging right there as opposed to having it here. So it's almost like, again, you have that pencil and you use it a little bit and now all of a sudden it's a little bit dull. This is what happens, is that it's not so sharp when it hits the retina. And this is what nearsightedness is. So what nearsightedness is that you can't see things that are far away well, because the light, when you do, the light converges at this area right here. And this happens for nearsighted and farsightedness. It happens for a variety of reasons. Sometimes your eyeball is just too short or too long. Sometimes your lens muscles aren't working properly. That's why, like when you're older, sometimes you need glasses because these muscles just don't squish your lens as well and you can't focus as well as you might like to. So this is what nearsightedness is that it converges too early, and then ultimately you can't see things that are far away. And farsightedness is basically the opposite. These light rays come in, and same idea, instead of meeting at the sharp point right here, it meets basically in the back of your eyeball. That's where the light would converge if it could. So same idea, instead of when it hits the retina being really sharp, it's the light rays are spread out. So again, it's fuzzy when you look at something. It's not so sharp. And so this is farsightedness. So it's basically the opposite. You can't see things that are close because when you do, it doesn't let you focus them right there, it focuses it back there. So it's because the light focuses behind the retina. Both of them are the same big idea, that the light doesn't focus on the retina, and then ultimately it causes it to be fuzzy. It's just kind of a little backwards of one another. So luckily, we have glasses. So the way glasses work is that basically it fixes it. It puts a lens there, so instead of having your light rays meet in the beginning or before your retina, they put you wear special lenses. These are concave lenses, and then what it would do is it fix it to make sure it hits right where it's supposed to for the retina. The same for farsightedness. Instead of meeting back here, different type of glasses. You see the shape's a little different, but ultimately the end goal is the same, that the light meets there back at the retina, so you have a sharp image. So that's how glasses work, is that it fixes it to make sure the light hits the back of the retina like it's supposed to. And one last thing here is we have this thing called the blind spot in our eye. All of us have this. It's not some sort of disorder or anything else. And to me, it's really, really cool. So I told you there's the retina, which is the whole receiving end. But the thing is, there's this one spot that's the optic nerve, that's the highway, right? So over here, there is no retina because that's where the optic nerve is. So you actually have one little spot that if the light ray hits there, you can't see anything. Things literally disappear from your vision. And I'll show you what I mean in a second. So basically, like I said, it's a small spot on the back of the retina where there is really no receptors, okay? Because you can't detect any images because your optic nerve is there. So it's the spot that you can't really see images in the back of your eyeball. So this is a little test. Hopefully this will work on the screen. If not, you can kind of make your own on your paper and you'll get the same results. But you can see the directions right here. If you follow those directions and you stare at that number 3, what's ultimately going to happen is, depending on exactly where you move your computer screen, little by little, you'll get to a spot that magically the yellow dot disappears. And when that happens, that means that those light rays from that yellow dot are hitting that optic nerve spot, and there is no light receptors there. So therefore, you won't see anything there. You've hit that blind spot. So again, you can do it with this, or you can just put, like, honestly, I've done it where I just put like a little dot and like an X on a piece of paper, and the same idea, you move it close and far, and you'll see that the things will disappear. So that is your blind spot. And that's the main idea of how you see, how nearsightedness works, farsightedness works, and the general overview of what I would call a pretty complicated structure. All right, as always, thank you for watching, and let me know if I can help you at all.